Hi, this video is about different types of energy. Here we have a variety of different types of energy. The first one is kinetic energy or movement energy, and this comes from anything that moves. The next one is heat or thermal energy, and this is the energy that moves from hot objects to colder objects. Another type of energy is electrical energy, and this energy occurs whenever a current flows. We also have light energy, and this occurs when anything gives out light, such as a light bulb or the sun. Another type of energy is sound energy, and this occurs when any object gives out some noise. An example is a speaker. The next type of energy is nuclear energy, and this occurs when we have a nuclear reaction. A nuclear reaction releases nuclear energy. We also have gravitational potential energy, and this is energy coming from any object that has the potential to fall. Elastic potential energy is another energy type, and examples of objects that have elastic potential energy are springs and rubber bands. The final energy type that you need to know is chemical energy, and chemical energy is stored in fuels, food, and batteries. Energy can be transferred usefully from one form to another. It can also be stored or dissipated, which means spread out into the environment. But, and this is key, it can never be created or destroyed. A useful device will transfer one energy type to another type of energy that we desire. But not all of the inputted energy will be transferred into the useful energy, and some of the energy will be lost/wasted. The wasted energy will be lost into the surroundings. Here we have a diagram that explains this. We have our useful device, which is our box. We then put energy inputs into our useful device. Our useful device transfers some of these energy inputs into useful energy outputs, and these are the energy outputs that we desire. But not all of the energy goes into energy outputs, and some of the energy is wasted, and this is wasted energy. Usually the wasted energy is heat or sound. Let's use the example of a television. A television turns electrical energy into sound and light. However, some of the inputted energy is turned into heat, which is not a desirable type of energy. Let's use another example of a petrol-powered car. A car takes chemical energy, which is the petrol, and converts it into kinetic energy, heat energy, and sound energy. The kinetic energy is the useful energy output because this is the energy that we desire, but the other two energy types, the heat and the sound energy, are not required, and therefore they are wasted energy. A useful device will be more efficient with the less energy that it wastes. We can work out the energy efficiency by using this formula. Energy efficiency equals useful energy out divided by total energy in times 100, which gives us a percentage efficiency. If you do not know the energy inputs and outputs from the machine, but you do know the power inputs and outputs, you can still work out the machine's efficiency by using the following formula, which is energy efficiency equals useful power out divided by total power in times 100. We can use a Sankey diagram to show what proportion of the energy that goes into this useful device comes out as useful energy, and what proportion of the energy is wasted. So here we have a Sankey diagram for a light bulb. The width of the bar on the left shows us the amount of energy that goes into this useful device. And on this one, it actually shows us what type of energy it is. So we have 60 joules of electrical energy going into our light bulb. 60 joules of energy must also come out of this light bulb because energy cannot be created or destroyed. This means that the width of all the output arrows, which in this case there's two output arrows, we've got light and heat energy, must add up to the same width of the input arrow, which is the electrical energy. So our electrical energy comes out in two different energy forms. We've got light energy and heat energy. Light energy is the useful energy, and we can see from the diagram we have 7.5 joules of light energy, and heat energy is the wasteful energy because we do not want heat energy from our light bulb, and this gives us 52.5 joules of heat energy. A thicker arrow represents that more energy is coming out in that energy type. For example, we can see that the heat energy has a thicker arrow than light energy, and this is because 52.5 joules is coming out as heat energy and only 7.5 joules are coming out as light energy. From the information on the Sankey diagram, we can work out the energy efficiency of this light bulb. We do this by doing useful energy out divided by total energy in. The useful energy for the light bulb is light energy, and this is 7.5 joules. The total energy in is shown on the diagram by how much energy is going into the light bulb, which is 60 joules of electrical energy. So we do 7.5 joules divided by 60 joules times 100, which gives us an energy efficiency of 12.5%. Households are now more aware of how efficient the products that they use are. Also, as technology has progressed, firms are now able to design products that are now more efficient. In the exam, you may get asked to compare the efficiency of two different devices. You may also be asked to work out the payback time it takes for the efficiency savings from a new device to pay off the initial outlay for that new device. To work the payback time out, you do the initial outlay divided by the annual saving. There is a quiz question on this at the end of this section. For more videos, content, quizzes and past papers, go on to www.elevise.co.uk.